So today we're going to look at isomers. So firstly, what are isomers? So isomers are, uh, let's say, so isomers are using the same atom, same number of atoms. What structure or what difference can you make with that structure? Uh, that is what isomers actually is. So let's say we are given with 4 carbons, right? So let's say we are given with we are given with 4 carbons. So we have 1, 2, 3, 4. And let's say this was an alkane, so we have 10 hydrogens. So we had 10 hydrogens with this. So this was C4H10. So isomer actually is that using C4H10. So you're gonna have C4H10. So using this, what other alternative can you make something different or a characteristic that makes it a little different? So, for instance, what you could do was that this was butane. Now you can make this 3 carbon chain. So this is now propane, and let's say what you do with this carbon is that you put it here, you make it a branch. So you have 4 carbons. However, you do something different. So this group will be written in front, so it will be 2-methyl propane. So what you do is that you need to keep the number of atoms same, and keeping the number of atoms same, you have to do something different, or so that it becomes a little different in structure, in forms, in any way, so that the molecular formula is same, but the structure actually changes. So in isomerism, so we have to there are 2 types of it. One is which we learned in O levels. Which is the structural isomer. It is the structural isomer. And inside structural form isomer, we have chain isomer, we have positional isomer, we have functional isomers. And something that is new, we have to learn in A2 or AS, that is the stereoisomer. That's something new. So first one is literally very obvious. What you do is you play around with the structure. So you take this C there and that O there and do something different with that same molecule, and you have the same molecular formula like C4. You again have C4. This thing will be same throughout the isomerism concept. So this C4, and again in this also you have if you start off with C4 and something H10 blah 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 and whatever you have, so you are going to end up with the same formula. But in structural isomerism, what we did was like we changed the structure itself. We did something something so that this what we did was first the OH was here, and later what we do, we let's say we just uh, from these let's say it's in the 3rd carbon, so we just put it in the first carbon. So what happened was we just changed the position, and thus we changed the structure, so it was more obvious. But in stereoisomer, what we will see is that it's less about the structure, and it's more about from the angle. It's more about from the angle perspective. So you cannot differentiate using 2D structure. You have to draw 3D structure actually to understand stereoisomer. And it's less about the bond. Structural isomer was more about the bonding, more about the structural change. But this is more about the actually the angular or more about how at which like we will talk about this as we go in depth, as we move in front, as we move forward into the deeper into the isomerism concept. So first let's have a look at the structural isomers. So in structural isomers, what I say is structural isomers. Oh, where is that note that I had? Oh, so in structural isomer, first we have the chain isomer. So what is structural isomers? So if I am to write in definition, in terms of definition, what a structural isomer is, structural isomers are compound with it goes. Uh, mm, you don't have a special formula, but they are compounds with same molecular formula, but a different structural formula. If you are to write in your exam, like if you're given to write the definition, you're going to write this is a compound with same molecular formula, but different structural formula. I mean different structures actually. So first of all, we have chain isomers. So what are chain isomers? So chain isomers, if I write in terms of definition, I'm gonna say that they have like they play around with carbons actually. So they play around with chains. So you have four. You have a long chain. This is a chainless. This is a branchless molecule. This is a branchless compound. So this is butane. What you do is you play around with you make a chain. Uh, so now you get a propane. Now you get a propane and a group. So you keep the number of carbon same, but what you do is you play around with branches. So you have different chains. You have different chains. Uh, as many as chains you can make from four. You can just make one chain. So like one branch and have one isomer. If you had pentane, you could have two or three possible isomers. So that how chain isomers worked. So let's draw it. Oh yeah, I have the definition here. So chain isomers have different chains and branches of carbon atom. So as you can see here, right? So you have four carbon atoms. You still have four carbon atoms, but what you do is you make branches. And if you look at the skeletal formula, we have one, two, three, four. So we have four carbon and four ends. But in here, what we see is that we do have four carbons, one, two, three, and four. But what we see is that we take the last carbon and we put it as a branch. Similarly, if we had let's say one, two, three, four, five. Let's say we had hexane. So what we could do was we could take two of the carbon, uh, this and this. So the first branching would be same. So let's take it. Let's take so one, two, three, four, and we have two more carbons left. So five and six. So what we do is basically we take some of the carbons and we put it as a chain. So that what chain isomer is actually is. So that's it. So it depends, and you could also have like this that rather than having two carbons at two as a two chain, you could have one. We could rather have C2H6 rather than having CH3 and CH3 here, two methyl group. Rather than having two methyl group, you could have a propyl group. I mean, ethyl group. So that's how chain isomerism works. Moving on to position isomer. Position isomer is very straightforward and a very easy concept. So what you do is like you change the position of the functional group. You have different position of the same functional group. So this is an OH group. What you do is this was with the first carbon. Now what you do is you put it in the second carbon. That's that's how basic and easy positional isomers are. You just change the position of the what do you say, the functional group, and that is what actually I mean that is what it is. So moving on to the functional group. So in functional group, what you do is that like you have the same number of molecules, right? So you do something with the functional group. You try to break it, or you try to do something with the functional group. You have to keep the molecular number same. So you have different functional group as the functional group. So what you do is you manipulate the molecular formula as such, the structure as such, that the functional group itself changes. For instance, now we have an alcohol. We have three carbons and one alcohol, so it's a propanol. Now what you're gonna do is you're gonna mess up with this OH in such a way that it's no longer an alcohol, it's something else. So what we can do is you can take this O and put it in the middle, so it becomes something else. So first is this. The first thing we can do is this. We can also do something else. I mean, we are doing the same thing here. So we are getting this compound methane. Methoxymethane, something like that. So, so what you're doing is in functional group isomer, you mess up with the functional group itself. That you change the functional group. I mean, you change with the functional group, this group, the OH, the hydroxyl group. So you manipulate this to actually get something else. So for instance, carboxylic acid and ester. So you have both COO bonds and OH. So you mess up with something like you in ester you still have OH, you can say OH and O, but and you still have the same molecular formula and same, but the structure changes. You change the structure as such that the functional group itself changes. So that's what functional group isomer is. So moving on, and also we have an example. Uh, so yeah, so this is an ether actually, and having an oxygen in the middle. So you have the same number of hydrogens, same number you have O. You did leave the O, you have the O, but you messed up with the functional group itself to make something. So this was an alcohol and this is ether. So these are two types of component and they have a different reactivity. So functional group is a kind of isomer that has a lot of variance that can change the compound into a different compound, but keeping the molecular formula same. This is what you need to know. So atoms are rearranged in such a way that the functional group itself changes. So this was the structural form. This was the structural isomerism, and I think I should talk about the other isomerism, the stereoisomerism, in a separate video. So watch out for the next video, which will be in the playlist, and we will keep this class up, I mean, up till here. So goodbye.